Hello everyone, my name is Firas Shari. I'm CWNE 348. Today we're going to be talking about the OFDMA process that clients and APs go through to complete an OFDMA transmission in the A211A extender. This is going to be part of the fifth video in the series of the A211AX training. And I would argue this is probably going to be one of the most important one of all of them. Okay, so we have two types of OFDMA transmission in the standard. We have the uplink OFDMA and we have the downlink OFDMA. So let me start here with the downlink OFDMA. So a downlink OFDMA starts with the AP sending a modified or enhanced version of the RTS frame. It's the MU RTS frame. So basically, if the AP is trying to schedule an 80 megahertz OFDMA transmission, it will send an RTS, an MU RTS on each of the 20 megahertz, 20 sub channel 20 megahertz that constitute the whole 80 megahertz. So in an 80 megahertz, we have four 20 megahertz channel, 20 megahertz channel in an 80. So what the AB will do is going to send 4 copies of the MU RTS on each one of those sub channels. So the function of this MU RTS is to actually inform the clients that the AP wants them to schedule in and to want to schedule them for a downlink OFDMA transmission. Inform them that the AP is trying to reserve the medium and they need to reply back with the CTS with the CDS to inform the AP that the medium is available and the AB can go on and schedule the transmission. And also that will help the legacy clients to understand that there is a transmission, there is the AP is trying to reserve the medium for the upcoming OFDMA transmission, because the problem is legacy client will not understand that there is an OFDMA transmission going on. So the only part of actually OFDMA PBDU that they can decode is the preamble part of it. Okay, so like I said, it starts with an MU RTS frame. Then after a CIFS time, the clients will upload a CTS on each of those sub 20 megahertz channel back to the AP. After another CIFS time, the AP will start transmitting the downlink OFDMA frame to all the client that has been scheduled for this. And at this time, someone will ask, okay, so how does the client know that they're gonna be participating in this transmission? And what RU they're gonna be receiving data on, what RSSI they would expect, what MCS rate, and all those important information. So all of those information are added in the preamble. In the PBDU format video, we talked about a part of the preamble, which is the SIGB. So the SIGB is the part of the preamble that actually the AP includes all the information needed for the client participating on the downlink OFDMA for them to decode and demodulate the frames. So for example, let's say the AP is trying to schedule 4 clients, each one of them is 80 megahertz client, to do an OFDMA downlink transmission. So the AP will divide the 80 megahertz into 4 20 megahertz sub channels, which is an RU242 for each client. And in the SIGB, there are 2 parts. There is the common part and there is the per client part in the SIGB preamble part. So what the AP does, it will include all the information needed. It will tell each client, okay, so station 1, this is you're gonna be receiving on the first RU the 242 with this MCS rate, with this piece with the expected RSSI and all the other information needed, and so on for the other clients. So the SIGB will include all the information needed for all the clients. And all the OFDMA process need a very strict sync-in time. So that syncing time is driven from the shift time. So if we can see here, all the transmission starts by the end of a shift time. So the AP for at the first starts the OFDMA downlink transmission by transmitting a shift time. Then the client will reply back by a CTS after a shift time. Then after the CTS is uploaded, the AP will start transmitting to the clients after another shift time, and then the clients will send the acknowledgement on the uplink after another shift time. Okay, there is an interesting part here when it comes to the acknowledgement, uploading of the acknowledgement. The AP is actually capable of, incorporating a trigger, an uplink of DMA trigger with the data down to the clients that will sync the clients to upload the acknowledgement as an OFDMA uplink. So the whole downlink process can actually be a downlink uplink of DMA. It doesn't have to be only a downlink of DMA. Even the acknowledgement can be synced to be an uplink of DMA. So whatever happens in this side is actually can be explained by the process they're gonna talk about next, which is the uplink of DMA. Okay. So the other part is we need to focus on here, like all the information needed for an OFDMA transmission is sent on a 20 megahertz subchannel. So like for you to participate, or for a client to participate in an OFDMA transmission, it has to be able to listen to a 20 megahertz, and that is done because legacy clients can only understand the 20 megahertz chunks of bandwidth. They don't understand RUs as 26 RUs, which is a 2 megahertz channel, or RU 106, which is almost a 10 megahertz channel. So they cannot understand that. So every OFDMA transmission starts with setting up the transmission on a 20 megahertz chunk of bandwidth. But this was one of the, at least from my perspective, I've seen this misconception at the beginning with the early days of 8211AX, where people thought, okay, so now we can go all the way down to a 2 megahertz. That should increase my service period. So my service coverage area. So if I'm at the end of the cell and I'm doing 20 megahertz, if I would drop down to 2 megahertz, I can just go further and increase my coverage. So I mean, theoretically, it kind of makes sense, but it doesn't actually make sense in practical, because when you're scheduled to do an OFDMA transmission, you need first to hear the preamble, and all the preamble data is sent in a 20 megahertz format. So even if you're participating in an OFDMA transmission with a 2 megahertz chunk of bandwidth at 26 RU, you will still need to listen to the full 20 that carry on the preamble before you can actually tune that to 26 RU and receive your downlink transmission. So the service the service area did not increase in the 8211AX by lowering the bandwidth. Because if you divide your bandwidth by half, your SNR actually increased by 3 dB. So if you go from 40 to 20, you gain a 3 dB increase in bandwidth. So that's why people thought if they go for smaller RUs, they will be able to transmit from farther away from the AP. Okay. On the downlink side, all the OFDMA transmission, from the from the AP perspective, it's only one PBDU that is being sent on the downlink, right? It will create a full PBDU with all the information needed, loaded on all subcarriers, and it will send it on the downlink. On the other side, the client receiving, they will tune to a specific part of this transmission to receive, and they will leave the others out. So if you are scheduled to receive on an RU 26, you're only gonna tune to that part, and you're gonna leave the rest of the PBDU. But from the AP perspective, all of this is one whole PBDU. So there is no way the AP can send different length and time when it comes to the PBDU. So all the data going down to the clients, they have to have the same length. And for that to happen, sometimes the AP have to pad the rest of the frame to like reach the same length for all clients. That of course decreases the efficiency, but at the same time it helps with the legacy carriers, like the legacy client actually sensing the channel, so they can know there's a transmission still going on. So of course, if those clients cannot like generate an acknowledgement within a SIFS time, they would ask the AP to add also a packet extension that will give them more time to process the the frame and generate an acknowledgement within a SIFS time. The other thing that they have been added, the other feature that have been added to the 802.11ax standard is the aggregation, is the ability to aggregate more than like a different quality of service loads. So let's say that the AP a voice and a voice and a best effort load package for those for the same client. In a downlink transmission, the AP can actually aggregate both of them in the same frame, on the downlink to save, for more efficiency. Instead of like sending, and have an empty frame with only like a voice and padding the other rest, it can actually fit more different quality of service, packets within the same frame. And also that applies to the uplink as well. So the clients can actually also do the same thing. They can like, aggregate different quality of service, access categories on the same uplink transmission. Okay, let's talk about the uplink. So if we, the uplink starts with a trigger frame, also what we call a basic trigger frame. So a basic trigger frame is what the AP use to schedule clients for an uplink. And that frame actually includes, that management frame includes all the information needed for all the clients that are going to be participating in this uplink transmission to, create a complete uplink transmission. So the AP will tell those clients, the RUs they're gonna be they're gonna be using information that will help them to, um, figure out what TX power they need to use for transmission, like if they need to use carrier sensing or not. All of that is included on the frame. So, and again, OFDMA in general, whether it's uplink or downlink, requires a very strict synchronization, time synchronization, and that is done by using the SIFS time as a reference to start and end the transmission. So after the trigger frame, all the clients are required to reply back and send their upload their data after a SIFS time. And the AP is required to send a multi-station black acknowledgement down to the clients after the SIFS time of the end of the uplink transmission. The multi-station block acknowledgement is a modified version, enhanced version of the block acknowledgement that we use in legacy client and legacy standard. It's basically the same concept. It's just instead of being targeted to one client, it actually has a list of all the clients that participated in the transmission, in the uplink transmission, and the AB will tell each one of them, what frames the AP received, what type of, what is missing, and what to expect next. Okay. Here, I hope this is I hope this is clear. I tried to put all the frames, the capture frames, in one slide so we can go through them. We're going to go through them at once. So this is a packet capture of the management frames for uplink OFDMA. So capturing OFDMA in general is a very tricky process in AX, and like it's much easier to actually look at the management frames that comes along with it. Since they are sent on a 20 megahertz, you can actually capture them with even a legacy client. You don't need an AX client to capture those. Those are like sent on a 20 megahertz, and all legacy clients can hear them. So it is better to look at management frames and and deduct conclude what was going on instead of actually trying to capture the OFDMA packet itself. Okay, so let's talk about the OFDMA here, the uplink OFDMA. The whole process, like we said, starts with a trigger frame, and in that trigger frame, there are two parts. There's the common part, which is it is targeted to all clients participating in the OFDMA uplink transmission, and there is per client or user information, and has a specific information for each client. So in this scenario, actually, we have an AB set to 160. Scheduling 4 AX200 clients. Each one of them is set to channel 160 to bandwidth 160 to participate in an uplink of DMA. So we'll see that the AP is actually dividing the bandwidth, the 160, into 40 chunks of bandwidth, in RU484, for each one of those clients to uplink their data. So if we see here, the first thing is the trigger type. So this is the type of trigger that the AP will use to schedule an uplink of DMA. So there is multiple others. There you have the beamforming pooling trigger. You have the PSR, the buffer stator report. So, I believe there are like 7 of them. If you go through the standard, there's this value can go from 0 to 7. So you have like 8 of them. But I don't remember all of them. I remember the important ones that you usually see. You have the basic trigger frame. You have the beamforming feedback pooling trigger. You have the PSR, which is buffer stator report. Those are like the more important ones that you see on a regular basis. Okay, you can see also here that the AB, like you can see, like CS required is true. So the AB is telling those clients, even though that you have to participate, you're gonna be participating on the uplink of DMA, you have to use carrier syncing before actually uploading your data. And also then, for example, it's telling them that the whole uplink is an 80 plus 80 or 160. I'll also telling them that the guard interval and the long training field is also what type is being used. If there is multi-user environment, there is a bunch of important information here. One of them, the parts that I really want to touch on is the APTX power, which is a very interesting concept. So because from the AP perspective, what is being received on the from those clients on the uplink is a 1 PBTU. So it has to be strictly synced, whether in time or frequency, and actually TX level power. So the AP will tell all the clients what is the TX power while transmitting this trigger frame. So that will help the clients to actually calculate the path loss between the AP and the client. So the AP will tell those clients that what is the TX power when transmitting this trigger frame. The clients will have the RSSI from receiving the frame, and they can use that to actually calculate the path loss. So with this, the AP, the clients can actually, tune their ATX power to hit the AP with a specific RSSI. So if we go here to the second part of the trigger, which has information per client, we can see some of the important information. So for example, the first client, the AP is telling that the RU allocation is the primary 80. So because this is a 160 channel, you have your primary 80 and you have your secondary 80. So it's telling that client you're gonna be in the primary 80, and you're gonna be allocated to the RU65, which it's the first one. It's the first one of the it's the first 40 of the 80 of the primary 80. And then also it's gonna be telling it that you're gonna be using MCS6, and also it's gonna be your target RSSI is NIC 45. So this is the part where the client needs the information that was provided on the common part. So the AP told the client that the TX power was 11 dBm, and the receiving client, their client already have the RSSI for this management frame, the trigger. So now they can calculate the bath loss, and they can use that to actually calculate the TX power needed to hit the AB with a NIG 45. If we jump to the second client here, we can see that this client is being asked to participate on the secondary 80 megahertz, and it is asked to to use the RU allocation, like the first 40 megahertz of that secondary 80. Also, it is asked to hit the AB with NIG 47. So you can see here that the levels are very close. So the AB is trying to ask those clients to have a very close TX powers when it comes to transmitting, because on the other side it helps the AP when it's receiving all those subcarriers with a similar RSSI. Okay, here's the multi-station block acknowledgement. So in the multi-station block acknowledgement, we can see here that the type of the type of the frame. So it's multi-station block acknowledgement. We can also see here the association ID for each of the client. Asking each of the client the AP is transmitting this multi block acknowledgement to. So of course, those are like the association ID for all the client that participated on the uplink transmission. So we have 1, 2, 3, 4 of them. And then if we expand one of those, we can see here the bitmap for each one, for each client. We can see like all the the missing client, what has been received, and what to expect from the clients in the upcoming transmissions. Okay, so the next we're gonna be talking about multi-user MIMO and SU MIMO. I hope this video was helpful and informative. I tried to simplify the process and actually I got a lot of the details, and I only included the important parts of the process, so it would be easier to understand and keep this video short. Thank you very much for watching this, and I hope you guys find this very useful.